In this videotape, we will study relationships among different variables. Very often, different variables are somehow related. We're going to be studying three types of relationships between variables. We will be studying direct variation, inverse variation, and joint variation. If two variables are related so that as x increases, two variables, say x and y, are related so that as x increases, y increases, or as x decreases, y also decreases, we say that the variable y varies directly with the variable x, or y is directly proportional to x. Either y varies directly with x, or y is directly proportional to x. If two variables, x and y, are related so that as x increases, y also increases, or the other way around, as x decreases, y decreases. That is, they're changing in the same direction. We will say that the variable y varies directly with the variable x, or y is directly proportional to x. We can express this relationship algebraically in the following way. Y equals kx, where k is a constant. It's a non-zero constant called the proportionality constant. It's a non-zero constant. It's called the proportionality constant, or the constant of proportionality. It could also be called the constant of variation. Okay? Sometimes, instead of saying y is directly proportional to x, you might hear y is directly proportional to, say, the cube of x, in which case we would write y is proportional to x cubed. Y is directly proportional to the cube of x. We could write y is directly proportional to the square root of x in the following way. Y is k times the square root of x. We can use any constant, k, c, anything like that. And there's nothing sacred about x and y. We might have, for example, s is directly proportional to the square of t. Or s varies directly with the square of t. And we could write that s equals kt squared. The letters s and t often occur in a physics class. And this has some actual meaning here. We could say that if you consider a body dropping from rest, say through the air, s could represent the distance traveled. It is true that the distance traveled by the object is directly proportional to the square of the time it has been traveling. And we're going to see an example with that in a few moments. Now, when information is given about how two variables x and y are related, very often we can determine the constant of proportionality k. And once we have that, we can go on to give we can, for example, if we know some other value of x, determine what the corresponding value of y might be. Let's try an example. For example, y varies directly with x if y is 10 when x is 2. Find y when x is 4. Y varies directly with x, or y is directly proportional to x, can be written down like that, y equals kx. Now we are told that if y is 10 when x is 2. Okay, that is when y is 10, x is 2. Okay, using that, it's possible to solve for k, the proportionality constant. We have that 10 is equal to 2k, dividing both sides by 2, we can solve and find out that k is 5. We now know that the relationship can be written as y equals 5x. And using this, we will now be able to find y when x is 4. So they give you, in a sense, a point on the curve. We're told that when x is 2, y is 10. We substitute in and we figure out k, which we know actually corresponds to the slope of this line. In this case, k is 5. We now have an equation of a line, and we want to figure out a y value knowing an x value. So find y when x is 4. Y is 5x. Y is going to be 5 times 4. Y is equal to 20. Is the answer to the problem. So we first wrote down the direct proportion relationship. We determined the proportionality constant, and then we solved the problem. For our next example, we have the following. The one that I mentioned earlier about s and t. S, the distance a body falls from rest toward Earth is directly proportional to the square of the time t it has been falling. Okay, S is directly proportional to the square of t. The distance a body falls from rest towards Earth is directly proportional to the square of the time it has been falling. Okay, if a body falls 16 feet in 1 second, how far will it fall in 3 seconds? This is very similar to the preceding problem. We start by writing down that s is directly proportional to the square of t. We are told the relationship between s and t. A body falls 16 feet in 1 second. That's like saying when t is 1, s is 16. And this is asking for what is s when t is 3. Okay. So really, this translates to if s is 16 when t is 1, what is s when t is 3? Now it looks much more like the preceding problem. If s, the distance it fell, 16 feet, when it was after 1 second, how far will it fall in 3 seconds? Okay, let's go over here. We know that s is 16 when t is 1. S is 16 when t is 1. From this we can determine that k is equal to 16. Having determined what k is, we can now write the equation as s is equal to 16 t squared. We still have that s is directly proportional to the square of t, but we now know the constant of proportionality. Okay, we can now determine what is s when t is 3. Okay, what is s when t equals 3? So we substitute in t equal to 3, and we get that s is 16 times 3 squared, 16 times 9, or 144 feet. In other words, how far will it fall in 3 seconds? 144 feet. So far in each example, we had the variables directly related to each other. That is, they were directly proportional. As one variable increased, the other variable increased. Okay? Now, it might happen that it works the other way. If two variables, x and y, are related so that as x increases, y decreases, or vice versa. In other words, as x decreases, y increases. Okay, or vice versa. We say that the variables vary inversely with each other, or y is inversely proportional to x. Okay, and we can write this algebraically in the following way. Y is equal to k over x, where k is the proportionality constant. Now, notice the difference between this and what we had before. Before we had y is directly proportional to x. Y equals kx. Okay, as x got bigger, y got bigger. Okay, as x increased, y increased. As x decreased, y decreased. Okay, here, y is inversely proportional to x. The bigger x gets here, okay, we're assuming that the constant here is positive. Okay, the bigger x gets here, y is going to be getting smaller. You'll be dividing by a bigger quantity, y will be getting smaller. As x will increase, y will be decreasing. Okay, the other way around, as x would be decreasing, you'd be dividing by a smaller and smaller number, y would be increasing. Okay, so it's a different type of relationship. Here we have y is directly proportional to x. Y is equal to kx. And here we have y is inversely proportional to x. Y is equal to k over x. Okay, let's try an example with the inverse proportion. Y is inversely proportional to the square of x. If y is 9 when x is 2, find y when x is 3. Either y is inversely proportional to the square of x, or y varies inversely with the square of x. Okay, we're told if y is 9 when x is 2, we want to find y when x is 3. We start by writing down the relationship y is equal to k over x squared. Y is inversely proportional, k over the square of x, k over x squared. Now we are told y is 9 when x is 3. So we let y be 9 and x is 3. Oh, excuse me here, if y is 9 when x is 2. Okay. Y is inversely proportional to the square of x. Y equals k over x squared. We're told that y is 9 when x is 2. So we let y be 9 and x be 2, or 9 is equal to k over 4. We now multiply both sides of this equation by 4 to solve, and we get that k is equal to 36. Okay, 4 times 9 is 36. Here the 4's cancel, so k is equal to 36. Y is 9 when x is 2. 9 is equal to k over 2 squared. 9 equals k over 4. Multiplying both sides by 4 or cross-multiplying, we get k equals 36. So we now know that y is equal to 36 over x squared. Y equals k over x squared, or 36 over x squared. And all that remains is for us to find y when x is 3. Okay, so we substitute in x equal to 3 now that we know k. We get y is equal to 36 over 3 squared, or 9. Y is equal to 4. Notice that x has increased from 2 to 3, but y has decreased from 9 to 4. They're varying in the opposite direction. X has increased, but y has decreased. Unlike, say, the first example, where x was going from 2 to 4, and y went from 10 to 20. Okay, in that case, x and y were both increasing. Here, x has increased from 2 to 3, but y has decreased. They're varying in the opposite direction. Now, sometimes more than 2 variables are involved in the problem. And if we have, say, one variable varying directly with 2 other variables, we say that they vary jointly. We say that the variable varies jointly with the 2 other variables. If the variable z, let's say, varies directly with 2 other variables, x and y, we say that z varies jointly with x and y. And we could write that as z is proportional, z equals kxy, meaning it's proportional to both x and y. Okay, we might write z varies jointly with x and the square of r in the following way. Z is directly proportional to x and the square of r. Z is k times x, r squared. And you can also get an inverse relationship when you have more than two variables. For example, you might write z is directly proportional to x and inversely proportional to y. And we would write that z is directly proportional to x and inversely proportional to y. In other words, we have here the direct relationship. Z is directly proportional to x. And if we block out the x, we see it is inversely proportional to y. And it can be done by means of one equation. Okay, let's try an example when we have more than two variables. Z varies jointly with x and the square of y. If z is 200 when x is 2 and y is 5, find z when x is 5 and y is 2. And this will be our last example on this tape. Z varies jointly with x and the square of y. We would write down that z is equal to k xy squared. We are now told that z is 200 when x is 2 and y is 5. And from this, we will be able to find k. Z is 200 when x is 2 and y is 5. That is 200 is k times, now 5 squared, that's 5 times 5 is 25 times 2. 200 is equal to 50k. Dividing both sides by 50, we get that k is equal to 4. So we have now that z is equal to kxy squared, or 4xy squared. Okay, we're told z was 200 when x is 2 and y is 5. From that, we could figure out that k was equal to 4. Now we know what the equation is. We know what k is. Find z now when x is 5 and y is 2. That's what we're up to. Find z when x is 5 and y is 2. Okay, so we want to find z. X is now 5 and y is 2. So that's 4 times 5, 2 squared, that's 4. 4 times 5, that's 20, times 4 is 80. So our answer is that z is 80 when x is 5 and y is 2. And that brings us to the end of our tape.